Let's see if I can control it from here. See, it looks like you've overridden me or something. I don't have control. Alrighty, tape number 2. Collins talking, 6.0 Translunar Coast. Item 1, IMU realignment. Alright, we realigned the IMU in Earth parking orbit, and the next time we realigned it, we were, I guess, inertially fixed. And as a general comment, I found that the telescope was a very poor optical instrument in that it required long periods of dark adaptation before any star patterns were visible. And in most cases, it was not convenient to stop and spend the amount of time which was really necessary to make any use of the telescope, so that being as how we kept our platform powered up continually, my procedure was to ignore the telescope and to take at face value what the sextant said. In other words, if the sextant auto-optics came up with A star in the sextant field of view, I accepted as a matter of faith that was the correct star and did in fact mark on that star without any further verification. I suppose this is a procedure that under certain dispersed circumstances could rise up and bite you, but I felt safe and comfortable with it, and it worked throughout the flight. Doffing PGAs. There were, as far as I can recall, no surprises in doffing the PGAs. They took,
who was first?
I believe Neil, did you take yours off first? I was last.
I think I took
No,
mine off
Buzz
first,
took
yeah.
his off first.
Buzz took his off
I
first.
wanted to stow that in the back because I was going to be the last one to put it on reefer. Anyway, you were going to put yours on before I did.
Probably is just worth mentioning here that as a result of the pre-launch day that we spent in the CMS practicing taking the suits off and stowing them in their right place and in the right order and so on, we decided to put all suits in the L-shaped bag with mics in the top and Buzz's suit in the bottom of the bottom section to the rear, which is the upward edge or the head end of the couch, and mine in the lower part of the L-shaped bag in the lower section. And that worked fine as we'd practiced it. All 3 suits did go in the L-shaped bag satisfactorily and could be stowed there. We left them out, though, for some period of time prior to stowing them to allow them to air out, since they had been worn for a significant period of time prior to this, and we wanted to try to dry them out before putting them in the bag for 3 days. And that worked as we planned, and we think that's a reasonable procedure.
Folding them, taking a little bit of care seemed to pay off when you got to the point of wrestling with them to stuff them in. If you did it in a somewhat methodical way, like putting one arm ring inside the helmet ring, putting the other one in the chest, and I actually zipped all the zippers up, and then folding it over the gas connectors, and then running both legs over and around and getting it as tight as you can before putting it in. Well, it went in sideways so that as you looked, when the suit was in there, why, it was in a roll, looking end on at it, and it seemed to fit into the position quite well. No doubt about it, it was a bit of a wrestling match to do this and stuff it in there without much of a restraint system to work with. But it just took a little bit of extra time and effort.
Maybe we're a little overprotective. I doubt that you could really damage those airlock connectors and helmet rings and so on, but it was our intent to treat those with as much caution as we could, since we were really committed to their successful operation later.
I'd like to back up here one and go back to this IMU realignment. I note here that, I remember now that our X torquing angle was 0.172 degrees the first time, which seemed excessive to me, and we asked the ground, and they said it seemed excessive to them, and to go ahead and redo it and see what the results came up with the second time. So I went through P52 the second time, and instead of 0.172, I got 0.171. Both those are with minus signs in front of them. So, being as how those results were repeated, the ground said go ahead and torque them, and we did. I don't understand why that torquing angle was as large. I guess it's probably just an uncompensated X drift, which they later compensated for more accurately, because the platform was well within its limits during the remainder of the flight, and yet this does seem like a large torquing angle. Another general comment about the IMU realign is that, or any of the IMU work, I couldn't get consistent star angle difference numbers. I got, at various times in the flight, I got either 5 balls, 0.01, or 0.02, and there was no correlation. As a matter of fact, there was negative correlation. The more time I took and the more precise I attempted to be, the more often I got 0.01. And on a couple of marks, when I got 5 balls, I know that I was not precisely centered when I took the mark. So I think that there's some small bias error in that sextant. And that...
How'd you do in your last eye check?
I know it. I'm opening myself up to all kinds of ridicule here, but I really think there's some small bias error, because several times, if I just noticed it once, I wouldn't say it, but several times I noticed I was maybe slightly off on a mark. I can remember a couple times I was just a little bit low into the left when I marked, and the damn thing would come up with 5 balls, and another time I'd be precisely on, and it would come up with 0.01, or even one time 0.02. So I just record that as an oddity. I think it's down the noise level, but I think there was a small bias error. Okay, optics calibration worked all right. Now, there really is no category in here for P23, so I think I might just as well talk P23 at this juncture.
Item 13.
Oh, is it item 13? Okay, well, then let's press on. Photography, Earth and Moon. Moon we weren't taking at this time, Earth we were. We'll have to wait and see how the pictures came out. System anomalies, I don't believe we had any.
Well, at this time, I think we were starting to home in on the O2 flow discrepancy.
Yeah.
And we talked about earlier, I'm not sure we understand that completely, except for the fact that the gauge was not apparently indicating the correct flow level, and it was varying with time. Its indication for what we think might be a particular flow was varying with time, and as evidenced by the fact that the water accumulator cycle flow rate continued to decrease until it got down to about 0.3, and then it went back up to 0.4.
It would register on there each time, and initially it seemed to go up almost to the fake value, which led me to believe that there's nothing wrong with our gauge.
Sounded like the transducer was faulty, but not disconnected. I mean, it definitely, the gauge was operable, but it was just out of calibration.
Right.
And its degree of of out of tolerance or its degree of inaccuracy seem to change from time to time. ECS redundancy, I'm not sure what this involves here, this comment, but I would just say generally we spend a lot of time with ECOM before the flight discussing what items to check and what items not to check, and I suppose as long as we have space flights we're going to have philosophical disagreements on how exhaustively you want to check all the equipment. My personal philosophy is it's a damn thing. If you don't have some reason to believe that it's broken, leave it alone. Don't fool around with it. And the FODs, of course, have a bunch of mission rules, and they want to verify each and every component of each and every system to make sure that they're not going to violate one of their mission rules, and I can understand that viewpoint. And maybe the truth lies somewhere in the middle, I don't know, but we ended up, after many discussions, checking the secondary loop to include the operation of the secondary, to make sure that the glycol would flow satisfactorily through the secondary radiators without any leaks, and to make sure that the secondary water boiler was functioning properly. We did that pre-TLI, and then pre-LOI we checked only for gross radiator leaks and did not check secondary water boiler operation. That's one way of doing business, and as I say, it's the result of many meetings, and I suppose with many more meetings you could come up with some other way of doing business. I really don't know what to say about that.
Well, it wasn't any difficult or time-consuming task. It went fairly smoothly. It's just a question of whether you want to do it or not.
It's a question of whether you want to do it, but if you'll recall, for example, on the secondary glycol radiator leak check, you put the secondary glycol loop has been bypassed. That is, no fluid has been allowed to go through the radiators. So you put the valve from bypass to flow for 30 seconds, turn the pump on and allow fluid to flow through the radiators, and you confirm that there is no leak by checking the accumulator quantity and making sure that it does not decrease. Alright, so what happened? In this case, accumulator quantity decreased by about 4%. Well, this had never come up before. The ground suspected that it was due to thermal characteristics and contractions or expansions in the system, and therefore it was no leak, and because it dropped and then stabilized it was okay. But I just have the feeling that you open yourself to, I don't know, I'd prefer to just leave that equipment alone rather than mess with it. I guess there was no leak, and on the other hand, we could have gotten I think we could have gotten into a hell of a big argument over a suspected possible leak or a suspected small leak, and even gotten to the point where we might have to delay TLI a rev because of that. And I verge toward, if you don't have concrete evidence that something has malfunctioned and it's your backup system, well, leave it alone. Don't mess with it. I don't know what you guys want to say about that. I'm not sure that you agree with that. But
No further comment.
yeah. Okay. Chlorinate the potable water. We did that once a day before bedtime. The little injector assembly got more and more difficult to operate as each day went by. I think the chlorine tends to stick and corrode the screw threads, and what started out to be a fairly low torque job toward the 8th day got to be pretty darn difficult to screw the container down so that the chlorine capsule within it would get squashed, if you know what I mean. We also got some leakage the first day due to the fact that I did not have the threads fully engaged, and all I can say there is try to, well, I don't know what I can say there. I felt to me as if I did have the threads engaged, and when I started screwing it down, I found I didn't, and chlorine was escaping, and I had to get a towel out and mop it up. After that, I didn't have any trouble with it.
Well, it's a procedure that you just not like to have to put up with. I found myself invariably wanting a drink of water of some sort after we chlorinated the water. You couldn't do that unless you put some in a bag ahead of time. Maybe we should have done that. It just didn't occur to us until afterward.
Yeah, I'm not sure it's at all necessary. I guess those germs truly can swim upstream through all the valving. It's, you know, for future spacecraft, I don't think I'd try to fight changing the system for mainline Apollo. For future spacecraft, you'd certainly like some built-in way of assuring yourself of a germ-free water supply without having to go through this kind of a crude procedure once a day. Communication setup for rest periods. Buzz, you want to talk about that one?
Well, I thought the way that the flight plan handled it seemed a little involved. We were in a translunar switch setup, and then it would say each time for a rest period, go to lunar coast except for such and such. Now in the LEM, we had a fairly simple way of handling it. We just labeled right straight on down the line the position of the switches. And I think we could probably come up with something similar to this that could include just a certain set number of switches that are all S-band, and you just make a quick check of all of these and have them in the right configuration instead of having to refer back to the systems management book for your switch positions, except for a couple of them that were mentioned in there.
Well, what we've done generally is to try to, when there are a bunch of words involved in a checklist, is, you know, fairly lengthy checklist, is to keep that checklist out of the flight plan and keep it in the checklist. And I don't know. I know what you're saying. The flight plan people prefer it the way it is, naturally enough.
The problem with this particular one, and I think it's maybe the only one of similar items in the checklist, is that the accept list becomes pretty long. And so you end up with a fairly complex piece of list in the flight plan, and also a complex list in the systems book that you have to go.
Well, there are probably a dozen switches that they want you to check, 15 maybe, something like that in that S-band, and I guess you could print them all 15 up in the flight plan and leave them out of the checklist or put them both places. I really don't know.
But the flight plan does have two options of the sleep mode, either the high gain one or the omnibus.
Yeah.
You either go one way or the other, so you really have more than you need in the flight plan.
And just, I guess for the record here, we ought to mention that we insisted on only going in the Omni mode during sleep periods. That's a philosophical question, and one that we're glad to discuss.
Okay, pre-sleep and post-sleep checklist. I thought that was reasonable. Do I get any comment about that? Ease of operations of communications and adequacy of communication procedures. Now, and remember, this is just during translunar coast we're talking. I guess I thought they were all right, but I guess there were also times when we had communications dropouts that I don't think were explained. I had the feeling that there were a lot of ground antenna switching problems. There'd be times when we really should have had comm and we didn't. and it was due to some sort of a ground problem. Just qualitatively, it seemed to me that there were a lot more of those problems on this flight than there were, say, on Apollo 8.
I agree with that.
Well, we get
You probably noticed that in the center too. Handovers and switching and so on. They seem to get procedural problems or something very frequently, and that was kind of surprising to us.
Well, we chose not to be playing the game of controlling it on board and switching from one Omni to the other. We let the ground handle the whole thing, and when they just have a choice between two Omnis, they are going to run into some dropouts invariably.
At the PTC rate we use of 0.3 of a degree per second, for the crew to switch Omnis manually and go around A, B, C, D during the time when they're away is really too much of a job, because you're having to switch Omnis every, I forget the number, but it's like every 5 minutes or so.
That's about right. I think it's 18 minutes.
So it's, I think it was a correct decision to let the ground switch between opposite B and D Omni antennas rather than having us switch manually A, B, C, D. But I guess the ground needs some refinement of that procedure, because we did have innumerable cases of comm dropouts, and later on in lunar orbit it was even more so. Preferred PTC mode and technique for initiation. There are all sorts of little buried funnies in the checklist. PTC page L9-6 for how to get into PTC. Now, just for one small example, during the period when you are waiting for the thruster firing activity to quiet down, there's a 20-minute nominal wait period for thruster firing to diminish. And just as one small, for instance, if the crew wants to see how the thruster firing activity is coming along, then their way of usually of doing it is going verb 16, noun 20, and monitoring the gimbal angles, and watching the lack of change of those gimbal angles. And yet, if you do that and leave verb 16, noun 20 display on the disk key, when you come 8 or 10 steps later to the point where you start to spin the spacecraft up, instead of getting 0.3 of a degree per second rate, you will get a rate in excess of 1 degree per second. And this fact was not clearly known. That's something that we found in the simulator shortly before the flight and penciled into the checklist. But I would just say in general that that checklist should be reworked. There are many little pitfalls, and if for example, another for instance is if you find yourself in an initial attitude and all you want to do is spin up around that attitude, the checklist implies that you can just go into it at that intermediate point. But that is not the case either. You must pretend that you are in the wrong attitude, ask the computer to maneuver you to the right attitude, and then go through the entire checklist from that viewpoint, or it won't work properly. And those are just two pitfalls that I happen to know about right now.
It seems to me that the point is that this was a very good procedure that works extremely well, and we're going to find it extremely useful, but it hasn't stood the test of time yet, and it needs a lot more experience in its use before we could use it reliably and repeatably every time without causing a later problem that we couldn't predict.
That's right. Another little facet of it is after the PTC is initiated, then there are certain no-nos in regard to use of the disk key, having to do with collapsing deadbands and other problems internal to the computer. So I think some explanation and expansion of those pages in the checklist is in order.
It's probably worth noting here while we think about it that there seems to be some advantage to writing a program to do this job. At least it ought to be considered.
Yeah.
Rather than the method we're using at the present time, which could obviate a lot of the kind of little difficulties that we've been mentioning up to now.
Okay, the next item is P23. And P23, as I practiced it in the simulator, made use of the auto optics to maneuver the spacecraft to each star's substellar point. The flaw in this technique is that the spacecraft roll angle is unconstrained, and that for large trunnion angles, the computer may pick a roll attitude which causes the star to be occulted by LEM structure. Now, the flight planners came to me a couple of weeks before the flight and said that to get around this disadvantage of the auto optics, they wanted to use ground computed angles to which to maneuver, and then these ground computed angles would have a roll angle which would assure that the star would not be occulted by LEM structure. And at that time I told them that all my training had been built toward using the auto optics for these maneuvers, and I asked them to go back and find stars whose trunnion angle was small enough that this would not be a problem, the LEM structure occulting. And they went back, Guillory went back and talked to the MPAD people and said that they could not find such stars with the proper in-plane, out-of-plane geometry, but that the ground computed angles would locate the substellar point satisfactorily, and that all subsequent maneuvers, if required, would be very small ones. Well, I should have just called a halt right there and sat down with the flight planning people and with the MPAD people, and I should have gone through each star, each maneuver, each gimbal angle, each subsequent substellar point, and ironed out just exactly, step by step, how many maneuvers would be required, the size of them, and what exactly was being furnished me in regard to roll angles. But I didn't. It was one of the things that fell through the crack. So, in flight, when I maneuvered to the ground supplied angles, I found that I was nowhere near the substellar point for the star, as determined by the fact that the sextant reticle was not parallel to the horizon at that point. And here I think we had some kind of a communications breakdown with the ground, because I kept telling them that this was I was not at a satisfactory substellar point, that the reticle was not parallel to the horizon, and they kept telling me that that was all right to go ahead and mark anyway. And I'm not sure exactly.
They didn't really mean that. We're sure they didn't.
We're sure they didn't
But it
mean
sounded
that,
like
but they
that's
kept
what they
saying
said.
that. They kept saying that. Now, I'm not sure what they meant. I guess maybe you hit the nail on the head. What they meant was that the spacecraft did not have to be rolled so that the spacecraft roll was parallel to the substellar point. In other words, what they were saying was that the computer program could accommodate a change in spacecraft roll simply by torquing the optics around to go off at a peculiar angle. But nonetheless, when you look through the sextant, to get accurate marks, you must have the reticle pattern parallel to the horizon, or you are not measuring the true angle between the star and the horizon. Here's the star, here's the horizon. Instead of measuring this angle, you're measuring this angle or that angle or some other oblique angle that is larger than the true angle, which is the angle from the star normal to the horizon. So this initial run on P23 got very confused, And the following day, the problem went away because we were far enough away from the Earth that the fact that their angles were not at the substellar point became immaterial, because the Earth was small enough that a very small maneuver on my part could locate the substellar point. But when you are close to the Earth, and the Earth is very large, and you have an obvious roll misalignment in the reticle, then it requires a very large maneuver to maneuver the spacecraft over to the substellar point. This is sort of hard to understand without a blackboard, but I'll be happy to draw it on a blackboard some other time for the proper people. I was reluctant to make these large maneuvers because I thought something was wrong, and they kept saying, "Go ahead and mark, it's all right." And so I did take some marks, and the delta R's and the delta V's were excessive. I don't know what else to say now. I'd sort of like to get a blackboard and talk this over with Ted Guillory and with the people from MPAD if necessary, and see where we went wrong here. I think it was probably initially it's my fault in that I didn't get all the interested parties and sit down and go through step by step and maneuver by maneuver exactly where we were going to go and what we were going to do.
Don't you think it's one of these areas that it would have been nice, maybe for you anyway, to have had abbreviated SIM with Houston as part of our training? The only problem there is that you just can't always count on the simulator giving you enough fidelity.
I think that's one of the areas where the simulator probably falls a little short in some of those areas to point out those kinds of problems.
In my mind, it's a question just of time available. I mean, to me, I had so much stuff to learn, and I had divvied up the time, and P23 was a relatively small slice of the pie, and I didn't want to really spend the time to sit down and go and hammer this stuff all the way through, but I really should have.
That's possible.
What did they conclude? Well, that's another thing. The state vector was another thing.
The state vector may have been good initially, but when we got two large errors in a row, we incorporated it, and at that point, then from that point on, the state vector wasn't any good.
That's right. The state vector was mediocre to begin with, and it rapidly got worse. But each star has its own distinct substellar point, and to take a measurement on two stars in a row requires you have to maneuver from one substellar point to another. And I kept telling those people that before the flight, and they kept saying, no, they're all right close together there. And I think there's some confusion on their part, and admittedly some on mine.
I think it's also unfortunate that the first mark, or the first star set that we had, was changed from the flight plan.
Oh, that's another thing. Yeah, we didn't mark correctly. See, it always was star 2, star 40, star 44, and star 45. Well, then, sometime between the last time we simmed it and the first time we pulled this out in flight, star number 2 had been moved from number 1 position down to number 4 position, and they had done it just by changing the 1 to a 4 and drawing a little arrow. And when you read me the numbers, you didn't notice that. And I heard star number 2, and it was the same old star I'd always marked on first, and that contributed, I think, to the confusion. So that was just a bad area, and a little bit of work could have cleaned that up before the flight, and I just either didn't have the time or the inclination to sit down and hammer it out with the people required, and I should have. Worked fine the next day, but it worked fine the next day only because the Earth is so much smaller that if you know, if you got a little Earth like this, and you're supposed to be marking on this point, and you're at this point, it's no big deal to move from here over to here. But if the Earth is this strapping big, and you're supposed to be marking on this point, and you're really over there, then it's a hell of a big maneuver to maneuver across. The same problem existed the next day. It was just that, you know, a little tiny maneuver on my part could make that problem go away. Whereas the day before, it was a huge maneuver was required, and I was reluctant to make that maneuver. Okay. Ease of handling optics in spacecraft for nav sightings. Well, I think we've covered that in the previous comment. Adequacy of procedures to prepare for and accomplish the translunar midcourse corrections. Now, by that I assume they mean ground supplied solutions, and that I thought was fine. Anybody have any comments about that?
Well, they may also be referring to our P30, P40 sequence and so on. And it was our intention to do those very carefully and just the way they're detailed in the procedures. Not because the burn was all that important and we couldn't compensate it for it if we made an error, but rather because the analysis of that burn on the ground was going to be the thing that determined that we have a good SPS for LOI. Since that was the case, we wanted the ground not to be at all confused about what procedures we used and just how the burn was made. So we tried to stick precisely with the same procedures you'd use for a big SPS burn.
In general, though, I thought all the P30, P40 worked out very smoothly. Midcourse correction, external delta V, EMS delta V, any numbers?
Well, the first midcourse was canceled to allow the midcourse, the delta V value to grow in size, so that the second midcourse correction would be a reasonably long burn in which the engine operation would be well stabilized and could be accurately analyzed on the ground. I think that midcourse 2 data
21.3 feet per second.
here. And the results of that were very, very good, and the residuals were very small, 0.30 and 0.2, but there was some question about the fact that we had a relatively large EMS residual, namely 3.8 feet per second and about a 20 foot per second burn, which indicated that we didn't really at all, since we knew the EMS was probably pretty good unless it had decayed rapidly since the previous burns. The predicted knowledge to tail off apparently was badly in error, or else the knowledge of the EMS itself in the tail off region was badly in error. That never was corrected throughout the flight. We saw those kinds of conditions through the rest of the SPS burns.
Don't say anything about the sextant star check. They updated that. Remember, it was pretty much out Z, at the Z axis.
Yes.
First one they gave us, and then the second one was still in that direction because of course the LEM was there.
It was our desire that insofar as possible your inertial attitude check for a burn be made as in the axis of the burn, so that if you made the burn, you knew you were in fact pointing in the right inertial direction. Of course, the limb is out in front of you, and you can't look down the x-axis with the optics, so you're constrained not to point any closer to the x-axis than the limb will allow. However, their initial values that they gave us were sort of like the z-axis, down the z-axis. Of course, you could have the optics pointing down the z-axis, and then you could be free to pass that test and still have the spacecraft pointing 180 degrees out from where you wanted it to be and still pass that test. So it was our view that that wasn't particularly a good way. You were really just checking the alignment of the platform, which is really not what you're trying to do. You're trying to check that the spacecraft is pointed the way you want to point, right? Not the platform is pointed the way you want to point. So that was the reason for our request for an additional star check there.
Okay, adequacy of all this stuff for during AGA reflectivity test, item 17. We didn't have that. We can cancel that. Television preparation and operation. I thought in general the onboard color television system was well designed and was easy to operate. Buzz, you got anything to say about that?
Quite easy to hook up and put together. We ended up on several of the putting the two together, making use of tape instead of the Velcro that was on there to get the monitor right close to the camera. I think the initial one we were a little tangled up in wires. There were wires all over the place, and we were running around from one strip to the other. And we found out that it was best to have the monitor attached right to the camera itself. So from that point on, while we taped the monitor to the side of the camera.
Well,
how's that cigar?
I have a couple comments that I'll get into sometime later with respect to television, but with respect to its operation here, that's unquestionably a magnificent little piece of equipment, but you cannot operate it without any planning at all. You do have to think about whether the vehicle is going to be rotating or not, in what area you're going to take pictures, where the lighting is going to be from, and through what windows, and all that sort of thing. And it takes some planning to enable you to assure yourself that you are going to get a good TV picture of whatever you've decided you want to take a picture of.
That's right, and the monkey is on the back of the crew, really, to be a script writer, a producer, actor, and whatnot for these GD television shows, and we had no time or inclination pre-flight to plan these things out. So they were all sort of spastic, spur of the moment, oh my Lord, turn the television on, we'll think of something kind of shows, and maybe that's a good way to do business, and maybe that's not. I don't know. Maybe for other flights with perhaps more time to devote to this, they should give some thought to what's been done before, what has not been done, what's the best thing to cover, or when is the best time to cover it, and then maybe go through in the simulator one time and work out things like angles and lights and whatnot.
If you're going to do it, there's no doubt that you want to do it right, because there's a big audience looking on.
Yeah, I mean, it's bad to just go up there and completely flub the thing, you know.
Always got to find what ends you right and what they may apply when it's something really good.
It bothers you a little bit when all of a sudden you got about 10 minutes left to go till a scheduled TV broadcast, and they come and set up and say, okay, here's where 200 people in the world, 200 million people have been sitting around waiting for this minute. They're all watching now. What are you going to show them?
Yeah.
I mean, we're trying to paint the picture of having this highly trained professional crew, you know, and it looks like 3 stumble bums up there. They don't know where to point the camera or what to do or what to say, and you know, it hasn't been well worked out. It may, I'd say it just made us uncomfortable. At least I felt uncomfortable about
It's just
television.
just fortunate that the camera's as good as it is and can compensate for the inabilities of the operators.
I think some of the better things we did were just monitoring and trying things out before we got to the point of putting on the show. And I think if there's the ability of people on the ground to see what's coming across and select what they want to out of this and look at it in some delay and then assemble it together and then release it. Of course, I'm sure that everyone wants to have real time voice along with it, but you're going to suffer some in the quality of what you get. For example, activity in the LEM was, we were just trying to see how it was working, and then all of a sudden we found that we were going out, and we were completely happy with that. That was probably one of the better ones that we did.
What do you say?
Yeah, could be a candidate for him. I agree with that, but on the other hand, there's another side to that discussion too, that involves somebody at least thinking about how that situation can be handled, and you can put out something that the agency is willing to stand behind and can be proud of without the crew having to make a lot of last-minute quick guesses as to what they ought to be doing. Okay.
Okay, high gain antenna performance. Worked all right, I guess.
Seemed to work fine, and get it into auto and throw the switch over to medium or narrow, and just a couple seconds later, why the signal strength would zap on up there to a high level.
There was one observation there that seemed to me to be different from the simulator. In the spacecraft, I could seldom, if ever, detect the difference in signal strength between medium and narrow. While in the simulator, it's always decidedly different. Now, this led to one of 2 possible conclusions. Either our simulator is not an accurate representation of signal strength, or 2, that we really weren't getting any difference between medium and narrow beam. We were in fact stuck in one or the other, irrespective of which switch of position.
I would have said there wasn't as much difference between the wide and the medium, but when you went to the narrow, you could see it. But it wasn't consistent.
In any case, it was unlike what we were used to, but as long as the signal's getting back, I guess that's not a problem.
Yeah, I think it's a function of your distance too. Now, in the lunar orbit, there was a noticeable difference between medium and narrow.
Mm-hmm.
When were you talking about? Mostly
Lunar distance.
at lunar distance. Because I noticed more the opposite. I noticed less of a difference between wide and medium, and more of a difference between medium and narrow. But there were some funnies in that high gain antenna, and I think some of them are that we were playing with it sometime and we didn't have control over it. When the ground had one of the omnis selected, and therefore we were seeing, we thought we were controlling it when we weren't. That was one funny. And another funny was that there were ground switching problems where the thing was not receiving a proper signal.
I remember one time the ground said, go ahead and turn the high gain off or do something, and I went ahead and did it, and we lost comm. And I don't think they expected us to lose comm. The next time, they had control, and we were on an omni at that time. It
Yeah, that's right, and it was a great temptation to go to command reset to make sure that we had control, except that throws 6 or 8 other switches, which
Yeah.
we were reluctant to change. So I don't know what to say about that high gain end. I guess I'd have to say that I don't think, I suspected at times that it was not working properly, but I never absolutely caught it malfunctioning. I think those suspicions mostly had to do with we didn't have control of it, or the ground had some sort of a sight
think
problem.
The confusion in my mind often was a result of the fact that I wasn't really sure what our configuration actually was. You can't tell by the switches, and trying to interpret what you see in terms of displays you have available and what you hear based on what you hear through your earphones still doesn't lead you to the right conclusion.
Yeah.
And that's a little bit disconcerting.
S-band reflectivity test, we didn't have that. S-band squelch worked very well, I thought. Anybody have any comments about squelch? No. Daylight IMU realign and star check. I think we've already covered that by saying that with the LEM on in the daylight, the telescope is nearly useless, and you have to rely on the sextant. Now, we never went into that mode that Apollo 10 discovered of pointing the plus x-axis at the sun. We never had an occasion to need to do that, and therefore can't comment on it. But just staying in regular PTC attitude, normal to the sunline, the telescope was just about useless. Venting batteries and waste. Anything to say about that?
No, when we'd start to do a battery charge, well, we'd look at the vent, and it was usually down fairly low. I don't think there was any time when we saw it up above 1.6.
1.6.
And as soon as we'd go to vent, where it dropped down to about 0.2 or 0.3. I don't know how serious a thing that is. Nobody seemed to be concerned about it. I'm sure the ground has a readout of that, but they never indicated or suggested to us that we vent the battery. It was just something that was up
Something
to
we
us.
did. We just go ahead and do it. Radiators. We never flowed through the secondary radiators. Primary radiators worked fine. The cabin temperature translunar was slightly warmer than we would like it, although the gauge readings were quite cool. We were running 60-degree cabin temp and 50-some degree suit temp. There.
High
For a while,
40s,
we were still
usually
warm.
high 40s in the suit and the low 60s in the cabin.
And yet we were warm, despite those low numbers. CM LEM delta pressure. Well, the LEM pressure would slowly decay, but it was well within tolerance. That's about all I can say on that. I don't have any good numbers for it, but it was a tight LEM, tight tunnel. Reestablishing PTC, we've already discussed that, I think. We always use 3/10 of a degree per second roll rate. We never tried the 1/10. 1/10 would have a lot of advantages in regard to antenna switching, and if the stability is satisfactory, 1/10 would be probably a better mode than 3/10. It would also save some gas, but we did not investigate that. Perhaps that ought to be something for a future flight to look into.
1/10?
Yeah.
The way it'll start to diverge at down around 0.22, so you have to be above that. According
Yeah,
to the
I've heard
one
that.
theory.
I've heard that both ways. I've heard it both ways. All I'm saying is that if it would work, 1/10 would have many advantages we did not try. As a matter of fact, well, it's neither here nor there, but I think that theory has been exploded. Somebody told me I was wrong.
Maybe.
High gain antenna PTC react check. I'm not sure that we did that. Did we ever check react during PTC? I don't believe we did. We did
Yeah, we did
lunar orbit.
We did coming back. Used React a couple times.
Yeah.
Mhm.
Yeah, we did.
Coming back.
And it worked okay.
Well, sometimes it worked, when it worked like a charm, or a couple times when it didn't seem to want to come in, maybe, when we were first experimenting with it.
Optics cal the next day worked fine. Fuel cells. Those fuel cells perform like a champ. Purging, I don't think had any surprises. We followed the checklist on the heaters and the purge and all that stuff, and they work normally. LEM and tunnel pressure, normal. Latches, as I say, the latches were all verified. Latch number 6 required 1 actuation to cock. That was the only funny, and that's within the realm of the normal. Inspection of tunnel mechanics. Not sure what that means, but everything up in the tunnel was normal. Probe and drogue removal was absolutely normal. IVT to LEM. Guys, anything you say about that?
Well, there was, as far as I'm concerned, none of this disorientation in going from one spacecraft to the other. It was very pleasant to have that increased distance to be able to move up and down, and it was quite easy to go from one to the other. It would take a little bit of readjusting to get yourself into position, and when you first would look in one vehicle or the other, you weren't sure what you were looking at, but there was no disorientation associated with that.
Yeah, I didn't observe any problems in this area either.
16 millimeter camera. Not sure what it refers to.
We may not get back to this again, but I think that exercise that we had in the LEM was extremely valuable from our standpoint. It was conducted under a very comfortable timeline. We weren't had no particular schedule to meet. We used this to document also the television at the same time, and I think that was quite valuable to people. I'm sure glad that we put that in.
I am too. From a CMP viewpoint, it's of great value if for no other reason than you have a 1-day head start on removing the probe and the drogue, and if you got any funnies or any problems with the probe and the drogue, gives you time to digest what they are and talk it over with the ground. I was glad to get that probe and drogue out a day early.
This is something, that hadn't been done before quite this way, and we really didn't have an awfully good reason for doing it. It just seemed like it would make us more comfortable in going back and forth to the LEM, and if there was anything wrong down there, we'd have some chances to talk about it and think about it, give the ground some time to think about it. That didn't turn out to be the case, that there were problems down there. As a matter of fact, it was perfect, but still, I think all of us felt a lot more comfortable having spent some time going back and forth and checking the stowage and thinking about
That was a hell of a morale boost and nothing else.
And looking over everything and doing a lot of things that we would have had to have done repeated the next day, and this just took the pressure off. And
But it let us do them under a very relaxed environment of the constant wear garment. Going in there was no problem. You didn't really need to be restrained. I used the restraints a little bit, and I think I gave a comment that all they seemed to do was to pull my pants down. It was, you did have to be a little concerned about floating away from what you were doing, but it was no big problem to push yourself back down to where you wanted to be.
did enable us to get a little ahead in stowage and transfer items, and
Well, we brought several books back and had updates and a couple of the procedures from the ground.
so all in all, I guess it just worked out well, and we think
We checked out each
we
camera.
recommend it as a useful procedure if there's no reason not to do it.
Yeah, we had 4 cameras in the lab, and we checked out each one of them on that one particular day and verified that they all worked.
Okay, eating periods, next item. They were well spaced, and I thought adequate time was given to eating. Quality of the food and all that, I don't know if we want to discuss that here or come in later.
There's a place there.
Okay. Workloads. The workload during a transmitter coast is very light and should be.
Well, in comparison to the workload pre-flight, it gave us a couple of days to relax, and I think to store up some rest, much needed rest.
I think so.
We all had good sleep period. The first one wasn't as good as the second and third, but that first sleep period was still surprisingly restful as far as I was concerned.
Yeah, I think particularly when you get into these later flights of extended EVAs and lunar activity, somehow the crew's got to get themselves in a frame of mind of looking on the the separation of the LEM as sort of the beginning of the flight plan, and all the events leading up to that, just don't sweat them. I mean, just somehow relax and get plenty of sleep and conserve your energy and get all rested up, because I think to arrive in lunar orbit tired is going to be bad scene, and that's possible to do if you don't approach it in the right frame of mind.
I think Mike's hit the nail on the head there. We did precisely that. We got a lot of rest and got to lunar orbit. They're raring to go to work, and that's a particularly fortunate position to be in.
This is something we talked about before the flight, and I don't know how you get yourself in that frame of mind, but I think it is a frame of mind. You have to get yourself convinced that that's going to be a nice, relaxing couple of days going to the moon, and get plenty of sleep and don't get worried about things. Lloyd, do you want to turn that thing on for a second?
It's not on, is it?
Yeah.
Is that one on?
Yeah, this thing here seems to. I seem to have lost control. Well, I mean, are we sure that we're recording?
There is a place for sighting somewhere, if I remember. Yeah. Maybe that's the thing. Okay. Let's see if we can recreate this.
Well, the first unusual thing that we saw, I guess, was maybe one day out, or it was coming pretty close to the moon. And we saw something that had a sizable dimension to it. So we put the monocular on it.
Wasn't this event preceded by something? Didn't we feel something, or we had some reason to? How do we see this thing? We just look out the window and there it was.
Yeah, and we weren't sure, but what it might not be the.
But I guess what I'm thinking of is, we thought it was S-IVB, and we called it ground. S-IVB was 6,000 miles away, or some number like that. So
6,000.
6,000. So it could have been. But I guess what I'm trying to say is, now I'm trying to go backwards in time in my mind, and I think that this thing had somehow separated from the space.
Yeah, we had a problem with the high gain back this time, didn't we?
Yeah, there was something. We felt a thump, or maybe I just imagined this, but I had some reason to think that whatever this thing was had separated.
I wonder whether
from the
Mason
space
had come
guy.
off, or. may be on the tape.
I don't guess we felt anything.
Well, of course, we were seeing all sorts of little objects going by from the various dumps. And then we happened to see this one brighter object going by, and we thought, well, couldn't think of anything else it could be other than S4B. We looked at it through the monocular, and it seemed to have a bit of an L shape to it.
Maybe something like this.
Like that.
Yeah, like an open book.
I called it
Sort of
maybe
like
an open suitcase.
We're in PTC at the time, so each one of us had a chance to take a look at this, and it certainly seemed to be in our vicinity and a fairly sizable dimension.
But we should say that it was right at the limit of resolution of the eye. It was very difficult to tell just what shape it was, and there was no way to tell the size without knowing the range, or the range without knowing the size.
So then I got down in the LEB and started looking for it in the optics and playing around with the focus.
Oh, the
Yeah, the sextant. And we got grossly misled because if you have that focus off, why, what we saw appeared to be a cylinder, and we all zapped right on in on that.
Or really two rings.
Yeah,
That's
there
what
were
it
two
really
rings.
looked like,
See.
two connected rings.
And it looked like a hollow cylinder.
No, it looked like a hollow cylinder. To me,
Yeah.
it didn't look like two connected rings. It looked like a hollow cylinder. You could see this thing tumbling, and when it came around end on, you could look right down its
Yeah,
guts,
yeah,
and there was
that's
a
right.
hollow
Like you're looking
cylinder.
at it.
Yeah. But then you could change the focus on the sextant, and that shape would utterly go away, and it would be replaced by this open book shape. It was weird. It was really weird.
I guess there's not too much more to say about it other than it wasn't a cylinder. It was some sort of a
Irregular kind of
It was during the period when we thought it was a cylinder that we inquired about the S4B, I
yeah,
guess.
and we started putting
Almost
some,
convinced ourselves that's what it had to be. It's on the tape.
but we don't have any more conclusions than that really, other than the fact that we didn't see it much past this one time period.
And we really don't have a conclusion as to what it might have been, or how big it was, or how far it was. Was something. It wasn't a part of a urine dump, we're pretty sure of that.
You know, when the, skipping ahead a little bit, but when we jettisoned the LEM, you know, we fired that explosive charge and got rid of the docking ring and the LEM, and boom, pieces came off the LEM. And it could have been like some strip of mylar or something that had somehow come loose from the LEM.
Well, we thought it could have been a panel. It didn't appear to have that shape at all.
A thrust deflector from the LEM, but except we could see, I don't know, I don't think it was quite that shape. That's right, and for some reason we thought it might have been part of the high gain antenna. That might have been about the time we had high gain antenna problem. And in the way in the back of my mind, I have some reason to suspect that its origin was from the spacecraft. I don't remember whether we felt a little thump prior to this, or maybe not. But it's a weirdo. I don't know what to say other than it's a weirdo.
And the other observation that I made gradually accumulated. I don't know whether, looking back on it, I saw it the first night, but I'm sure at least it was the second night, and trying to go to sleep with all the lights out. I observed what I thought were little flashes inside the cabin, spaced a couple of minutes apart, and I didn't think too much about it, other than just note in my mind that they continued to be there, and I couldn't explain why my eye would see these flashes. And I just chalked it up in my mind as being something that I had observed. Coming back, trans-Earth, why we had a bit more time, and I devoted more opportunity to try and investigate just what this could have been. And it was at that point that I was able to observe on two different occasions that instead of it being just one flash, why I could see double flashes at points separated by maybe a foot or something like that in the spacecraft. Other times I could see a line, no direction of motion. And the only thing that comes to my mind is that this is some sort of penetration, at least that's my guess without much to support it, some penetration of some object into the spacecraft that causes an emission as it enters the cabin itself. Sometimes it's one flash on entering, and of course it might leave in an entirely different part of the cabin outside of the field of view. But the doubles obviously, or it appeared anyway, to have been an entry and then an impact on something else, maybe the strut. For a while I thought it might have been some static electricity, because I was also able, in moving my hand up and down the sleep restraint, to generate very small sparks of static electricity. But there was a definite difference between the two as I observed it more and more. I tried to correlate this with the direction of the sun. When you put the window shades up, you still always have a small amount of leakage, and you can generally tell within 20 or 30 degrees which direction the sun is. It seemed as though they were coming from that general direction, but I really couldn't say that there was anywhere near enough evidence to support that these things were observable on the side of the spacecraft where the sun was. A little bit of evidence seemed to support this. And I asked the other guys if they'd seen any of these, and until I guess about the last day, where they hadn't seen anything.
Well, I'd seen some light, but I had just always attributed, since the window covers leak a little bit of light, no matter how tight, carefully you put them on, why I just thought there was a little bit of sunlight coming through a little hole in the window cover and bouncing off something over here.
That was my first reaction,
for sure, that's not
in moving around, the sun had the opportunity to glint directly in, and that's what I was seeing. But then it became apparent that wasn't it at all.
Yeah.
This was inside the spacecraft, and it didn't have to be completely dark.
That's the only time I observed it was at the last night when we really looked for it, and then I spent probably an hour watching the inside of the spacecraft carefully, and I probably made 100 observations maybe in that hour. Maybe not that many, maybe 50, but significant.
Sometimes a minute or two would go by, and then you'd see two within the space of 10 seconds. On an average, I'd say, just a guess, that it was maybe something like one a minute. If you saw 100 in an hour, why, that's within the order of magnitude, I think, of what we were seeing.
Maybe not 100, but, maybe 50, but it's large number.
Certainly more than enough to convince you that it wasn't an optical illusion. It did give you a rather funny feeling to think that, or to contemplate that something was zapping through the cabin. You know, wasn't anything
very easily could be something like Buzz suggests, namely a neutron or some kind of a small, atomic particle that's.
It was quite surprising that it would be in the visible spectrum.
Well, it's about mighty close to 5 o'clock here, and this is